It was discovered 100 years ago. It has been observed daily ever since. Detectives have kept building ever more sophisticated equipment. But its motion breaks human logic. The sharpest minds gave up long ago. But some still hold on to hope. The quantum entity. Get it if you can. Hi, I'm Firuza Enchilina, and you are watching Bold Science with Firuza. Get comfortable, grab some popcorn, because we are heading to a place where reality behaves as if it decided to play a prank on human logic. Welcome to the quantum world, the strangest, most unpredictable, and most fascinating corner of the universe. Let's begin. When we look around, everything seems calm and understandable. The table stays where it is. A mug doesn't vanish only to reappear a second later in another corner of the room. A ball, when thrown, follows a trajectory that's easy to calculate. But go one level down, to where electrons, protons, and everything that makes up our world actually live, and reality turns into a theater of the absurd. Let me warn you right away. What you are about to hear will sound like a magic trick, but it's not a trick, it's physics. Early physicists were convinced that the small world was simply a scaled-down version of the big one. Of course it was. There was a sun, the nucleus, there were planets, the electrons. Beautiful, logical, elegant. They were absolutely certain that tiny particles obeyed the same laws as stones, planets, machines, balls, everything we see around us. If we know the speed at which an electron is emitted and the direction it's moving, then we should be able to calculate where it will end up. But here's the problem. When they finally learned how to look closely enough, the picture fell apart completely. Imagine electrons. We launch them under identical conditions, in the same direction, with the same energy. It would seem they should fly the same way, right? After all, the laws are the same, but no. One electron suddenly veers slightly to the right, another to the left. A third shoots off in a completely unexpected direction. And no one can predict in advance where the next one will go. At first, scientists try to explain it away. Maybe we're missing something, maybe there are hidden parameters. But over the years, it became clear. No, this isn't our inexperience. This is the world itself. Real. Fundamental. Now grab your popcorn, because this is where the story reaches the point that's often summed up in words attributed to Feynman. If you understand the double slit experiment, you understand quantum mechanics. More precisely, he believed that the entire fundamental strangeness of quantum mechanics is concentrated in the double slit experiment. He put it this way: if you can understand this experiment, you understand quantum mechanics. So imagine a screen with two tiny slits. We fire electrons at it, one at a time, one after another. If only the first slit is open, the electron passes strictly through it and hits some random point on the screen. If only the second slit is open, the same thing happens, except the spot appears in a different place. The electron goes through the second slit and lands somewhere on the screen. So, with just one slit open, everything works simply and predictably. One slit, one pass, one point on the screen. All clear. But when both slits are open, madness begins. The electron flies and ends up in places where it couldn't possibly arrive. Places where you cannot draw a straight line from the starting point. The conclusion: the electron passes through both slits at the same time, as if it split itself, took multiple paths, and interfered with itself. This is not magic. This is everyday life of the quantum world. Scientists thought, okay, let's just look and see which slit it goes through. So they placed detectors right at the slit, one detector next to each slit. These devices were meant to record just one thing: which slit the electron entered, the left one or the right one. They turned the detectors on, and something incredible happened. The moment observation began, the electron no longer went through both slits at once. It chose a single definite path. In other words, the very act of observation, the simple fact that someone was watching the electron, changed the particle's behavior. The quantum world behaves as if it responds to attention. It sounds like mysticism, but it's an experimental fact. We're used to thinking that the world around us is a logical system, that everything follows laws, that everything is predictable. But in the quantum world, a different logic applies, or rather, almost none at all. Particles can take multiple paths at once, can behave like a wave or like a particle, change their behavior when we observe them, and refuse to let us predict their trajectory. Reality, at its deepest level, doesn't resemble a well-tuned clock. It resembles an ocean of probabilities. And what's truly astonishing is that this is exactly what the world we live in is built from. Our calm, stable, logical world. And here's what I want to say in closing. Every day we look at the universe with confidence that we understand it. But beneath atoms, beneath molecules, beneath every centimeter of space, there lies a world stranger than any surrealist novel. And it is this world that determines everything. The light in your lamps, chemical reactions, how smartphones work, the structure of matter, reality itself. That's both unsettling and mesmerizing at the same time. And most importantly, it's only the beginning. You've been watching Bold Science with Firuza. Subscribe and leave a like. That comes next will be even more fascinating. We'll talk about what particles hide, how they deceive space, and why the universe itself plays a double game. Get your popcorn ready. Big ideas favor the bold.